biology, looking at edible insect flowers. We'll just talk briefly on the physiochemical properties and functional properties of these edible insects for sustainable food production. It was the year 1975 when Victor Meyer-Roschow wrote what is equivalent to a newspaper article posing the question, can insects help to ease the problem of world food shortage? You know what happened? Some people mocked him. Some people laughed at him. Others said he was crazy. But he also had others who were on his side, who were quick to point out that even in the Bible, we are told that John the Baptist, in the days of the wilderness, when he was proclaiming to the world that the Son of Man is coming, he was consuming edible insects in the form of grasshoppers as his protein source. So consuming edible insects is not a strange phenomenon. But after that, nothing really happened from a scientific point of view to further elucidate on this question. In 2013, another scientist from Wageningen University's Arnold van Hees, working with under the auspices of the Food and Agricultural Organization, released a document which was proposing edible insects for food and feed security. Such a document was downloaded 1 million times within the first 24 hours. And then the question is, why now the sudden interest on edible insects? So there are a number of things that we can look at when we talk of edible insects. So we look at sustainability. Edible insects offer an alternative to traditional livestock in a sense that they require less space for cultivation, less water, and they emit less green gas emissions, which then makes them suitable alternatives for incorporation in food products for sustainable protein source. So edible insects, they are also rich in proteins, minerals, some of the fats, and also amino acids. Therefore, this now opens up opportunities for development of new food products. In terms of food security, as I've mentioned, the world population is expected to reach 9 billion people by the year 2030. And this marked increase is going to be very high in the African continent, and therefore it's going to put a lot of strain in terms of the requirement for proteins. But for us as Africans, and also in other countries or continents such as Asia and Latin America, insects are not a strange phenomenon. They have been consumed as traditional food practices. In these days, sometimes you see some other people, they consume them as a delicacy. What we see now is that there is a global shift, especially in the Western countries, where they are also beginning to embrace the consumption of edible insects. In the European Union, they have released a regulatory framework which indicates what type of insects are permitted in food products. In Singapore, they've released a regulatory framework which allows for the incorporation of 12 edible insects in the food supply chain. So, for us in South Africa, we don't have a regulatory framework for incorporation of edible insects in food products. What we see is just that there is a mention of Mopani worms in passing, right? But if you've seen from 2019 from the media, there's been a number of headlines which indicates that there's also this renewed interest. We've seen former finance minister, may his soul rest in peace, who was destigmatizing the practice of consuming insects because he was cooking a lot of Mopani worms on Twitter. We've worked with some colleagues who've produced ice cream from maggots or from black soldier fly, which indicates the possibility and the potentials for edible insects. So what have we done, or what is important in terms of these edible insects? So there's 4 things that are important, which is the flowers, the proteins, the lipids, and the chitin. In our research area, we focus on the 3, which is the flowers, proteins, and lipids. But today, I don't want to say a lot, but I just want to show you or share with you the work that we have done with the edible insect flowers. Am I too fast? Okay. So, with regards to the edible insect flowers, we have looked at 3 insect flowers, which is 2 termites and a black soldier fly, which is a mopani worm, black soldier fly, and what we call mazuru. And we've done a number of studies. So what I just want to share with you is basically based on what we look at called the techno-functional properties. So what are these techno-functional properties? So techno-functional properties are what we call physical, or in some cases chemical characteristics of a flower that determines the behavior and the interaction of the flower as an ingredient in a food system during food processing. Why is this important? This is important because we know what consumers are saying. If I started with a question by asking you how many of you eat edible insects, I was going to get a lot of frowns, right? But literature and research indicates that people are saying they are willing to consume edible insects only if they are incorporated in food products in an unrecognizable form. So in other words, if they are incorporated as ingredients. So that is why we are interested on working with the flowers. So therefore, if we want to use them as ingredients or as novel ingredients or functional ingredients, therefore the techno-functional properties, those properties which govern the behavior during processing, then they become very important. And so here I want to highlight what we call the water binding capacity. So what is the water binding capacity? It is that ability of the ingredient, in this case we are going to be talking about the flower to retain moisture or water. And so these characteristics is very important or advantageous in products that require moisture retention, such as biscuits, emulsions, and other meat products. So what do we see? We see that, for example, if we have the termites here, mazuru and mopani worm, they are very high in water binding capacity compared to the black soldier fly. But then the other important attribute is the emulsion capacity, the ability to form and stabilize emulsions. So emulsions are those things we call water and oil don't mix together, so those they make an emulsion. So if we want to prepare emulsions, so we'll see that a black soldier fly has a high emulsion capacity, which is around 67%. So therefore that particular product or that particular flour can be used in applications such as mayonnaise, and also if you're doing some sausages, right? So we also wanted to look at the antioxidant properties of these things. So what we see, just in summary, we see that mazuru as a termite is very high in the DPPH radical scavenging activity, meaning it could be particularly important or effective in food products that require enhanced oxidative stability, and these are products that can be high in lipids, or in some cases these are baked goods. But what we then also did was to do a principal component analysis, and from this principal component analysis over here, it clearly showed that these flowers, they have unique antioxidant benefits, particularly they've got unique antioxidant benefits, making them versatile ingredients for improving the stability and the nutritional quality of a variety of food products, because we can clearly separate them based on a number of variables or attributes that were analyzed. And so now that we already see, especially what I showed you, the first attribute, which is the water binding capacity. Remember I said this is good for what kind of products again? Biscuits, right? So what we then did, our research was informed by the previous study that we've done. So we went on to produce biscuits, testing the applicability of what we have found. And so we characterized now firstly the flowers, and then we characterized the biscuits. And I must also say that we've done some microbiological studies, and the biscuits were safe for human consumption. What I want to bring to your attention is the sensory evaluation results. So what we find here from this study is that based on the panel of people that tested these products, they indicated that the inclusion of an insect flower in producing biscuits, if you exceed 15 to 20%, then that product receives less acceptability, meaning you have to work within 5 and 10% of the inclusion to have an overall acceptability which is similar to that of wheat flour. So now we are still doing some of the work in terms of the application of these edible insects. So the question that we are asking ourselves as a research group is, so where to? So where do we go from here with this research? What we want to do is to destigmatize the practice of consuming edible insects by positioning our products not necessarily as products that are just for poor people. We can also produce products which are locally based and in different applications, because we already have the technical know-how in terms of the knowledge of the antioxidants and the techno-functional properties. So it means we can play around with a number of products from the South African context. So we'll be looking at Edwin, beer with insects. So it's something that can potentially work. And so this work is not complete without the mention of the students and the team that we worked with. It is work that was funded by the NRF Tutuga grant. And so we acknowledge the contributions from the NRF Tutuga. And thank you very much for your time.